This video will cover critical thinking skills. Several critical thinking skills are valuable when teaching computational thinking. These should be incorporated into all code.org lessons. They include compare and contrast, cause and effect, prediction, problem solving, planning, and observation. This video will discuss each strategy and how the strategies can be used in computational thinking. Comparing and contrasting can help students organize information, which is important in computational thinking. Examples to use with the code.org lessons include comparing and contrasting written steps and code, an algorithm versus a computer, and in some of the programming, behaviors are used versus events. Programs create the behaviors of computing devices. With an event, one thing causes another to happen. This will not necessarily be incorporated in every lesson, but you will start to see those in the more advanced courses. Cause and effect. When students are developing programs or debugging their programs, they will want to consider what input will create the desired actions. Examples to use with the code.org lessons is a cause and effect with clicking run. What does clicking run cause to happen? Clicking on an object. The cause is clicking on the object, and the effect may be for the object to start spinning. There are also opportunities for students to learn about typing an input and what the computer program will do with that input, what effect different inputs will have. Predicting is related to cause and effect. Students can predict what will happen when they change a variable in their code. They should predict what the program will do before clicking on run so they can determine if the program behaved as they expected. Encourage students to make predictions rather than taking a trial and error approach to programming. Making predictions will strengthen their critical thinking skills. Problem solving begins with understanding the problem. Students often jump into devising a solution before ensuring that they understand what problem they are trying to solve. And once they identify that problem, being able to develop a plan, and then in programming, to be able to write a program to solve that problem. One way to slow students down in problem solving is in this planning stage. Have them decompose the larger problem into smaller parts. They can then plan a solution for each component task and build their program. And lastly, observation involves noticing. In critical thinking, it is important to look for the subtle details that may not be seen at first glance. In computational thinking, observation can help students identify new problems and find bugs in their solutions. You can incorporate these critical thinking skills in the code.org lessons, as well as any other opportunities you have to develop computational thinking skills with your students. We cover the ways to include these critical thinking skills in the videos that introduce each of the lessons in each of the courses.